Imagine spending thousands on precision tooling, only to find out your parts didn't need to be that perfect in the first place. It's actually more common than you would think, and a costly mistake. In this video, we will break down what part tolerances are, the key differences between Tittle block and functional tolerances, and 4 steps to help set manufacturable tolerances. A part's tolerance defines the acceptable range of variation for each dimension in a die-cut part. Since perfect measurements are nearly impossible due to material behavior and production factors, tolerances establish the limits within which parts are still considered functional and usable. Even with careful converting, parts will have slight differences, and tolerances help ensure that the variances won't compromise performance. Tittle block tolerances are the default tolerances embedded in technical drawings, often copied from templates or other processes like CNC machining. These can be unnecessarily tight or entirely irrelevant for flexible material converting. Functional tolerances, on the other hand, are deliberately defined ranges based on what the part truly needs to perform in its role. We always warn against relying on Tittle block tolerances because doing so can result in extremely high tooling costs for male-female tools, which start at $25,000. Functional tolerances enable converters to build only as much precision as the part actually needs, which can drastically reduce initial and long-term cost and improve manufacturability. Tolerances play a significant role in determining whether a part can be used in a manual or automated process. Automated machines often require much tighter tolerances because sensors and automated applicators depend on precise alignment to function correctly. For example, a machine applying a label with a sensor must detect and place it within a very narrow range. Any deviation could cause failure or defects. If you wanted to fix that issue, you would have to install a camera with advanced programming and robotics to then pick up the label. In contrast, hand-applied parts don't need such high precision, and therefore don't require expensive tooling or tightly controlled tolerances. To set manufacturable tolerances effectively, there are 4 key steps to follow. First, it is essential to define what the part needs to do. Understanding the part's function provides the foundation for determining how precise the tolerances need to be and what level of variation can be tolerated without affecting performance. Second, you must define the overall shape of the part. This includes identifying which features need to remain in alignment, especially in multi-layer designs, and ensuring the tolerances account for any potential variation that could compromise functionality. The third step is selecting the right materials. Your chosen materials should help accomplish the part's function that we defined in the first step. Whether it be bonding, masking, or sticking to skin, the material has to work for your intended application and has to work with the other materials in your configuration as well. In addition, you also want to consider how you're going to manufacture your part at scale. Whether it be 100,000 parts a month or 1 million parts a week, you need to have a plan for how that's going to be accomplished. Different materials behave in specific ways during the die cutting process. Stretchy materials, such as spandex or certain foams, can distort when passing through the press and then contract afterward, leading to inconsistencies in dimensions. Similarly, some materials are heat sensitive and may expand or contract depending on environmental conditions, which can skew tolerances. Therefore, it is important to consult with a converter before committing to any material to ensure it supports the intended tolerances. The last step is to determine the functional tolerances. These are the actual ranges within which each measurement must fall to ensure the part works as intended. It's often helpful to create prototypes that reflect the upper and lower bounds of these tolerances and then test them for functionality. This process confirms whether the part can still perform under normal variance and helps avoid unnecessarily tight tolerances that could increase production costs. It will also help to define which features or measurements are critical to functionality. Every listed tolerance in a technical drawing should be intentional and necessary, particularly because tighter tolerances not only raise tooling costs, but can also slow down the production process. During the design phase, there are additional practices that can contribute significantly to success. Early collaboration with a converter is highly beneficial. When the design is still flexible, converters can help craft a plan for how you will scale this project from 100 parts to 1 million a week. They can offer insight into how to optimize it for die cutting, which can reduce the number of defective parts, simplify production setup, and reduce your overall costs. Another helpful tip is to bring the appropriate technical experts into the conversation early to ensure that critical design details are communicated accurately. This collaborative approach prevents misunderstandings and allows for more informed decisions regarding tolerances, tooling, and materials, ultimately leading to a more efficient and cost-effective manufacturing process. Working with a converter early and often is essential to defining die-cut tolerances that are both functional and cost-effective. An experienced converter like Strouse will help assess your design, material selection, and end-use application to ensure your project is designed for manufacturability and there's a plan to address future growth. They may suggest design tweaks or alternative materials that help improve yield and reduce cost. Ideally, you can take advantage of the sample part program early in the design phase to test your product for committing to full-scale production. Even if you're not ready for sampling, you can always reach out to us for additional support, or you can visit our Learning Center to read all about the aspects of the converting process. Thanks for watching.